We have a question here about a car on a horizontal surface. It may seem at first glance like you're not given enough information, but don't hesitate to draw a diagram. And at first you may want to draw a top view, which is fine. You can draw your top view of the car, and there is a frictional force that is acting toward the center. That says F sub F. There's a frictional force that's acting toward the center, because as with all of these problems, there's a centripetal force and something must provide the centripetal force. In this case, it's the friction providing the centripetal force. To see how the friction relates to other things, let's draw another diagram that's actually, I call it a front view, as though the car were coming at you. There's a normal force up and a force weight down. Those are equal because it's on a horizontal surface. There's a frictional force that is providing the centripetal force. I do the usual. I write down F sub C is equal to mv squared over r. The F sub C in this case is what? F sub F, yep, force of friction, is equal to mv squared over r. Now I'm going to just plug in for force of friction and look for some relationships. And this is where the video is going to be useful, because you should pause it right now and sort of try to finish the rest of this as you're watching this online. Mu force normal is equal to mv squared over r. All I did there was use the equation for friction, and I replaced this with this. That's all I did, was just a substitution. Next, I have to recognize that force normal is equal to what? Force weight. And by now we've gotten in the habit, instead of writing force weight, we just write mg. So we write mu mg is equal to mv squared over r. Again, because the normal force and the weight are equal. Something good happens, which is why you should, this is why you should never jump in and say, I don't have enough information, I can't get the friction without the weight, and I don't have the mass. Well, if you do the whole problem out, if you do all the algebra and write down the forces, you can see that the masses cancel. At this point, I'm going to pause the recording as we just crank out numbers, and I'll point out that we know R, we know mu, we know G, and we're just going to solve for V. And don't forget to take the square root at the end. Okay, so recording again, 22.57 is the velocity that I'm getting. Conceptually, that's meters per second because it's the velocity. Conceptually, what this means is it refers to at which it will begin to slip. This is a static coefficient of friction. That's a static coefficient of friction, which means that the wheels are not skidding, which is why anti-lock brakes are useful. They prevent the car from actually skidding or slipping. So that's a static coefficient of friction. What this kind of tells you is the maximum force that that friction can provide. Questions?